Looking at Chapter 3, Probability, Section 3.4, solve problems that involve the probability of mutually exclusive and non-mutually exclusive events. In this lesson, we will look at distinguishing between mutually exclusive, which are disjoint sets, and non-mutually exclusive events. Also, we will use Venn diagrams and the principle of inclusion, exclusion, to determine the probabilities of non-mutually exclusive events. Recall, the ratio of favorable outcomes to the total number of outcomes is probability. So we have to put what we want, the outcomes that are favorable to event A, over the total number of outcomes possible. Let's remind ourselves of what a Venn diagram looks like. In the Venn diagram, there are various regions. Elements in set A and B are also A intersect B. They're in both A and B. Elements in all of A or B is recognized by A union B. Of course, the red region, only red, not including the overlapping region, are elements in set A but are not in set B, so it's only A. And elements in the blue region are elements in set B and not in set A, so it's elements in only B. Let's recall the principle of inclusion and exclusion. The principle of inclusion and exclusion stated that the number of elements in the union of two sets is equal to the number of elements in A plus the number of elements in B, subtract the number of elements in both sets. That is, number of elements in A and plus the number of elements in B, and we would subtract the intersection since we've added it in already in A and in B, so we subtract it once. We can extend this to the probability of A or B. The probability of A union B would equal the probability of A plus the probability of B, subtract the probability of A intersect B. Mutually exclusive and non-mutually exclusive. If you're looking at a Venn diagram, if two sets are mutually exclusive, then they are disjoint, having no elements in common. Non-mutually exclusive are where elements would have, sets would have elements in common. And of course, the probability of A union B in mutually exclusive is just the probability of A plus the probability of B. In non-mutually exclusive, the probability of A union B is the probability of A plus the probability of B, subtract the probability of the intersect. Mutually exclusive or non-mutually exclusive. If event A is rolling an even number on a die, and event B is rolling a prime number, these would be non-mutually exclusive. Since when you roll an even number on a die, the number 2 is both even and prime. B, if you are selecting a gift, event A is selecting a gift that is edible. And event B is selecting a gift that is a cell phone. This would be mutually exclusive since you cannot get a cell phone that is edible. Let's look at an example. A class survey was completed. 63% play sports, 27% play a musical instrument, and 20% play neither sports nor a musical instrument. So we have sports and a musical instrument. If we look at 100% of the people surveyed, there's 100%. 20 do not play sports. 20% do not play sports or an instrument. So if we subtract the 20%, that will give us 80%. So the union of S and M would be 80%. Probability of S is equal to 63%. And the probability of M is equal to 27%. Together, this will equal 90%. Since it should only equal 80%, we can see that 10% are in the intersect, giving 53% only playing sports and 17% only playing a musical instrument. Notice everything inside this diagram must add up to 100%. The probability that Dave will make the hockey team is 2/3. The probability that he will make the swim team is 3/4. The probability that he will make both is 1/2. So we have the hockey team and we have the swim team. In adding 2/3 plus 3/4 plus 1/2, sorry, 2/3 plus 3/4, we see that that is more than 1. That is more than 1. Therefore, we know that these events are non-mutually exclusive. We see that the probability he will make both is 1/2. The probability that he will make the hockey team is 2/3. So 2/3 subtract 1/2 will give us 1/6 of a probability that he will make only the hockey team. The probability that he will make the swim team is 3/4. 3/4 subtract 1/2, 1/4. So 1/4 probability that he will make only the swim team. Now, so we have 1/6 plus 1/4 probability plus 1/2, which will give us 11/12. That means there's a 1 in 12 chance that he will not do either. He will not make the hockey team, nor will he make the swim team. So the probability that he will make at least one team will be the union, and that will be 11/12. The probability that he will make neither team is the 1/12. That will be the complement of the union. The probability that Nikki will study on Friday night is 0.7. The probability that she will go to the movies on Friday night is 0.3. The probability that she will do at least one of these activities, that is the union, at least one of these activities, the probability of the union of study and go to the movies is equal to 0.8. Yet we could see that the probability of going to the movies and to study is 1, which is more than 0.8. Therefore, the events are non-mutually exclusive. So no. Are they mutually exclusive? No, they are not. Since there's only supposed to be 0.8 in the union, yet we've accounted for 1. Sorry, that should be an M. And 0.2 must be in the intersect. That is, it's a 0.2 is a probability that she will do both on Friday night. That leaves 0.5 for only studying, and 0.1 for only going to the movies. There is also a 0.2 that she will do neither on Friday night. What is the probability that she will do both? That is 0.2 or 20%. The probability of Jim attending the conference is 0.7. The probability of Jim going for lunch is 0.6. The probability that Jim will do neither is 0.1. What is the probability that Jim will do both? Once again, if you would like, you could pause the clip, attempt this question on your own. I will continue with the solution. So Jim is going to the conference or going to lunch. The probability he would do neither is 0.1. That means that the probability of C union L will be 0.9. Yet the probability that he's going to the conference plus the probability that he's going for lunch is equal to 1.3, giving us that there's a 0.4 chance that he will do both. That leaves only going to the conference, 0.3, and only going to lunch, 0.2. You may want to pause the clip again and attempt this problem on your own. The probability that Rob will make spaghetti for dinner is 0.6. The probability he will go to the hockey game is 0.5. The probability that he will do both is 0.2. What is the probability he will have only spaghetti? What is the probability he will only attend the hockey game? And what is the probability he will neither go to the hockey game nor have spaghetti? So we have the hockey game and spaghetti. We always, when we're completing a Venn diagram, if we're given the intersect, we should always start with the intersection. And it says the probability he will make both or do both is 0.2. If the probability he will go to the hockey game is 0.5, and that leaves 0.3 for the probability that he will only go to the hockey game. The probability he will make spaghetti for dinner is 0.6. That leaves 0.4 being the probability that he will only make spaghetti. 0.4. The union adds up to be 0.9, giving us a 0.1 being the probability that he will do neither. The probability that he will only attend the hockey game would be 0.3, and the probability that he will neither go to the hockey game nor have spaghetti will be 0.1. We have to recall that probability are the outcomes, the number of outcomes favorable to event A over the total number of outcomes possible. A Venn diagram is useful in determining the probabilities of non-mutually exclusive events. If the probability of A and the probability of B sum to more than 1, then they must be non-mutually exclusive.